Welcome to another stair building education series. Let's go ahead and jump right into it with our first video. In my attempts to build easier stairs, I came up with this idea here. I've never seen it done before, and it might work for you. So what it is a stairway that's going to come in at a 90-degree angle on each one of the steps. And instead of mitering the center here and figuring out how to cut a stringer for this area, you're going to be able to use the stringers that you cut for the rest of the stairway. So you're going to cut one stringer as a pattern and then use it to cut all of the other stringers for the stairway. And I don't think I'm going to need a lot of narration in this one here because I think most of it is going to be self-explanatory. So let's go ahead and jump into this thing here. We are going to have the treads coming over from this side to this side, and then the ones on the other side will butt up against them, or you can leave a gap. I left an 1/8-inch gap here and would recommend doing that for lumber expansion. And for those of you who don't know, when lumber gets wet, it expands, and when it dries out, it can shrink, making them a little unsafer. And if that's the case, then this will definitely provide us with a better stairway. So let's go ahead and remove the decking and take a look at how the stringers connect, or the block in this case, to the other parts of the stairway. And as you notice here, this block lines up perfectly with the front riser on this side and the front riser on the other side, along with the next stringer. So here we have a nice straight line, and we would have the same on the other side, and that will be the same all the way up the stairway. And when it comes to fastening the stringers together, I would recommend pre-drilling holes for your nails or screws, especially within the distance of about 5 inches from the top. Otherwise, you could end up splitting a section of the stringer. And of course, if that happens, that will be another lesson learned. So hopefully not too difficult. We are going to attach the bottom piece to the next stringer and the next stringer to the next stringer and work our way up the stairway. And of course, I am doing this backwards because you are not going to assemble it this way. You are going to be starting at the top and working your way down. And of course, you can always do this on the other side. So instead of attaching this stringer to this one, you could rotate it 90 degrees and attach it to this stringer and then work your way down with the stringers being on the other side. And the main reason why I think this stairway is going to be a little easier to build is because you don't need to figure out the stair stringer that is going to come from this corner here to this corner here. And I'm not suggesting that's going to be difficult to do. However, it could be. So let's go ahead and remove the center section and start with our first stringer. And this stringer will be 1.5 inches longer than this stringer here. And you can see that at the top here with the ledger. So if you didn't want to cut it 1.5 inches longer, you could just simply extend the length of the ledger all the way to the edge here. So keep that in mind. This will be the only stringer that will need to be a little longer. The next stringer we are going to install will come from this line here in our pattern. And I'm not suggesting you need to cut a bunch of these stringers. Just simply grab your pattern, lay it on top of a 2x12 or whatever you're using for your stringers, and then draw a straight line off of the riser here when you're laying it out to create this part of the stairway. And then you will attach it to this one here. And the next stringer, you will simply draw a straight line off of this part. And for this one here, you will draw a straight line off of this section. And then, of course, you can simply cut a block for the last one, which will be the same as this section here. And hopefully that makes sense. So we are going to take this section here and install it right here. And then we are going to put this part right here over here. And I'm not about to suggest you need to cut this out of a stringer. Just grab a block, maybe a 2x6 or a 2x8, and cut this square piece from it so that you have something to nail nail your treads to, right? And of course, after you have got a straight edge and made sure that everything is lining up in both directions, and you're happy with the structural strength in this section, then you can go ahead and attach the treads or decking. However, if you don't think this is going to be strong enough, maybe you're going to be building a longer stairway, something with more than 5 steps, and you need a little more structural support, then go ahead and double up the stringers, and then maybe even use some building hardware if needed, or even some larger beams. Instead of using two 2x12s, you could always use a 4x12 or 4x14s, or add some type of support bracing, or even additional stringers like we have here, instead of doubling them up. So again, I'm just kind of throwing out some ideas here that might work for larger stairways. And I'm using the word might because if you're going to be building a stairway that might require a little more strength, then you might need to contact a structural engineer or use more building hardware and structural support bracing. And don't forget that the bracing can go underneath the stringers. You can always use straps instead of the framing anchors like we have here. And again, once you are happy with the stairway, you can nail the rest of the treads or decking on to create a stairway with this design. And if you don't know how to cut a stair stringer, then I would suggest checking out some of our other videos or going to the website and then checking out some of our books for more information about laying out or designing a stair stringer. Here's a quick observation I would like to share with you when it comes to mitered corners, stair treads that join at a 90-degree angle. And that would be the fact that the lumber can shrink, it can expand. Remember, wood expands when it is wet, and it shrinks when it dries out. If you have wood, you're going to be using wood for something like this that has 10% moisture in it, let's say, and it dries out, the lumber is going to shrink, you're going to end up with a gap. I have seen this too many times. I built a few stairs like this and quite frankly would try to avoid building them ever again just because of this situation here. Now, it's not uncommon for the wood to shrink, and you can see where the gaps are different. Here we got a wide gap here and it's tight in the front. And then here we have a gap that's almost equal. Same thing over here. And it's hard to actually tell whether or not the lumber is warping. This is another problem that you end up with. As the lumber warps in one direction, let's say that it's lower here but higher here, and then over here it's higher here and lower here, you end up with these variations that could cause little trip hazard. So a quarter of an inch in height could catch somebody's heel, could catch their shoelace. I've seen it happen before, heard about it. So not always going to be a good thing. Main point that I'm making in the video is that I would just like you to think about the materials you use, or the fact that you could simply redesign the stairway to eliminate this problem in the future. And it does. It's frustrating. I built a nice stairway like this for a spa. It went up to a spa, and I built it all out of redwood, and it looked nice when I was done. Within a year, it looked horrible, and a lot of it had to do with the lumber bowing, twisting, and the gaps in the miters. Now, it didn't just I had multiple miters. It wasn't just one corner. I think the corners went all the way around the spa, and it just didn't look good. Within 5 years, it was something we were tearing out. So, just a redesign idea. You could actually have the ramp come all the way over. You would just have one ramp going up, and then you would have a wall over here, handrail, something like that, or a wall. If the ramp went all the way over, you would have a wall that would go at the same height as the ramp, up 42 inches, something like that. You could have the stairs coming down straight here, eliminate this, again, have a guardrail here, and then have a guardrail coming down here at an angle. And then, of course, a grippable handrail would be nice. You don't see a grippable handrail for the handicap access or the stairway here. So I think you could actually redesign something. If this is something you really want, maybe you could use composite materials that aren't going to shrink or expand when wet, might have a little better wear and tear than regular lumber. Douglas fir, something like that. Redwood and cedar. This is softer wood. You know, it looks nice, but sometimes doesn't always work well because it is softer for stairs and landings. So anyway, that's it for this video. Don't forget to watch more of our videos to increase your knowledge about stair building and design so that you don't end up with something like this and regret it in the future. In this video, I will provide you with the top 5 stair building codes, in my opinion, that you will need to be aware of when building a set of stairs with a landing. And the first one on the list will be the minimum width of the stairway, and that will be 36 inches. Now, that is 36 inches after everything is finished, after the drywall has been installed and after any of the wood trim has been installed. So if you have a stairway that is going to be in between 2 walls, then you might want to allow for anything you're going to be adding to the side of those walls, like drywall, wood trim, or skirt board. Next up on the list will be the minimum headroom height, and that line will be measured from this line here, or the front of each step, but it will not be measured from the top of the step on any other part of the step. Again, it's going to be measured from this line here. You're going to go straight up plumb or vertically level, and again, it can be measured from the front of each step or from this line here. Next up will be the individual vertical rise. That will be a maximum. It cannot be larger than 7 3/4 of an inch. And I would strongly suggest that you check with your local building authorities, building departments, because they might not be using the codes from the 2021 International Building Code book. Next up, the minimum tread depth will be 10 inches. However, when I first started working, it was 9 inches, and the vertical riser height was 8 inches. Next up, let's go ahead and take a look at the minimum width or depth of the stair landing itself. And according to these building codes, the depth of the stair tread will need to be the same or larger than the width of the stairway. And that would be the same for the top or the bottom. So the depth of this landing here will need to be the width of this or larger. And this was something a long time ago that used to have a 36-inch minimum, which would be the same as the minimum width for a stairway. However, they have changed the verbiage on it. So again, these building codes are from the 2021 Residential Building Code book. And for the most part, these are building codes I like. However, if you do not like them, then check with your local building department to see if they have different building codes that might work better for your project or for you personally. In this video, we will take a look at what will be required if you have a winder stairway like this that might not meet current building codes, and you might even be having a problem with using. And when I say using, you might have tripped a few times on it and would like to fix it. Now, before you think about fixing it, this video will definitely provide you with something to think about. So let's go ahead and take a look at the winder steps dying into one point here, along with a 3-foot wide stairway and 10-inch treads. And I have built plenty of stairs like this before they changed the building codes. And I'm not going to go over all the reasons why these stairs are unsafe. However, I can tell you that the newer building codes require a 6-inch minimum measurement at the smallest section of the stair treads. That would be this area right here. And in order to make this work, we're going to have to go 10 3/8 of an inch larger in this direction here and in this direction here. So we're going to be able to work with our original 3-foot wide measurement here. And if the width of your stairway is a little shorter or longer, then you might need to adjust this measurement here. And most of the time when we have a situation like this, where we want to extend the stairway 10.5 inches in this direction, we're going to have to move a wall. And that's probably the biggest reason why you're not going to want to do this type of stairway modification. Next up, let's go ahead and move the floor plan view to the other side of the stairway so you can get an idea of what we're working with here. And then let's go ahead and zoom out to give you an idea of how far you will need to extend it in this direction and in this direction here to create this section of the stairway. And then I will go ahead and move this section here over to here. We'll just kind of lay it on top of it or build it into it to give you an idea of the adjustments you will need to make to the landing. And something like this might not work for every stairway. However, it will work for a stairway that you're going to be installing a finished material on top of, because you're going to be modifying the area underneath the finished materials, like carpeting or wood flooring. So again, you can kind of see here where the old stairway is over here and up here, and what is going to need to be added to it to make it work. For example, you might need to add a section like this, and a section like this. And again, this area will need to be located underneath the finishing of the stairway. And even though this video wasn't meant to provide you with building instructions, I can always provide those for you. Let me know in the comment area if you need step-by-step instructions. And if I get enough viewers who are interested in it, then I will definitely make another video. And for those of you who do not, you just need a general idea or even a few reasons why you might or might not want to do something like this, then this video will have done its job. So in reality, these would just be small sections that you would frame on top of each other to make it work out. And of course, these sections would need to be securely connected to the existing stairway. So again, let me know if you want me to put together a video on the framing of this, how to break it apart, move the walls or floors to make something like this work. Here is another video in our garage building series. And in this one, we are going to build 2 apartments over a 2-car garage and actually put a walkway around the building so that we can get up to our first level and then up to the second level. And we're going to have a gable roof. And of course, the gable roof is going to have a large attic. And I went ahead and designed the stairs like this. However, in the next video, I am going to provide you with a different example and a reason why I did it this way. And of course, the reason why I did it this way would have something to do with saving a few dollars. And in the next video, I will fix the roof. And for those of you who cannot see what is wrong with the roof, you will hear in a few seconds. And that will be the fact that the roof overhang could hit you in the head if you are just a little bit over 6 foot tall. However, you might not have known this if I didn't show it to you in the video. And again, that will be something I will be fixing in the next video. And for those of you who watch my videos regularly, this video is not meant to provide you with structural engineering information. And local building authorities and engineers might need to get involved in this project so that it doesn't fall down in case there is a small tornado, earthquake, or the big bad wolf comes along with some strong wind. Now the lower deck is going to be dropped a little bit along with the upper deck. And in this example, I have the corners mitered and the beams are sitting on top of a post. That might require some building hardware, of course. And in this example here, I went ahead and ran the beam all the way over to the next joist. However, you can stop it at the end of the wall here. And of course, that is what we did on the other side. And the drop here is just a little bit less than 2 inches. And this is actually a question I received today. The individual wanted to know what the maximum or minimum was for dropping a landing at a doorway. And even though the standard for this measurement has always been around 2 inches, I've noticed that some of these building codes have changed and might be 1 inch or less. And of course, our floor framing with 12-inch on center joist, our floor sheathing, and our walls. And in the first apartment, we will come into a living room. We'll have a bathroom, a kitchen, closet, and a bedroom. And let's go ahead and take a quick tour of this. And I've actually made a video on this one already as one apartment over a garage. You can always check that one out. And I have already done the plumbing for this one also. So make sure that you check those videos out, and they should be on our playlist and can be found at our website by clicking on the garage link. Another thing we will be doing will be to leave a 2-inch gap in between the outside of the wall framing and the outside of the stairway. And this will allow us to run our siding or our stucco behind the stairway and to avoid waterproofing the edge of the stairway. So again, a 2-inch gap here. And since we will not be nailing this stringer up against the wall, the stairway won't be as strong. So again, it's one of those things where you might do one thing to save a few dollars, but create other problems. And of course, the step down here is about 1 inch. We are using 1 1/8 subflooring here, along with 2x6 decking. Next up, let's take a look at how the stringers are attached to the beam here. And if you notice with the lower stairway, this measurement here is going to be a little shorter than the upper measurement, and I will explain that when we get there. And of course, this area here will need to be waterproofed, and I will try to address this in a future video. If I forget, feel free to remind me. And the upper stringers will sit on top of the decking. And again, we will have a 2-inch gap here. And for those of you wondering, well, how are they going to install stucco or nail the siding with the stairs in the way? Well, you're probably going to have to install that before you install the stairs. And again, that could create another problem like I was talking about. We solve one problem but create another problem. And the upper stairway stringers will be connecting to a cantilevered beam, and the deck will have 3 cantilevered joists that go back into the floor, along with our step down here. And sometimes it will work out if you use a smaller beam, and the beam will simply drop down in the floor and won't be flush with the top of the floor joist. So another thing to consider when building a project like this. And all of the joists except for this one are sitting right next to a floor joist. And the reason for that is so that I can nail the heck out of this joist and get a nice connection into the beam here and into the joist. However, this one needed to move over a little bit, so I used some spacers. So again, another idea that you might consider using along with your 16D nails. And I would imagine you could always run some bolts through this also. However, I don't know if that would be necessary. Another view of the drop down or the notch in the beams and the joist. And in order to have the beam next to this joist here, I needed to extend the upper section of the stringer here and had to make it about 2 inches longer. Otherwise, the beam would have been over a little bit and I wouldn't have been able to nail it into the floor joist. Next up, let's go ahead and take a look at the blocking here. And we're using the blocks here instead of a doubler. So usually a double joist is required underneath any walls that run parallel to the joist. However, in some cases you can install blocks, and something like this might save you a few dollars. Next up, let's go ahead and install our walls without the sheathing so that you can get a better understanding of why we're installing the blocks. And of course, the blocks are going to help to support these walls, whether they are load-bearing or non-load-bearing. And there's no need to install blocks with the walls that run perpendicular to the joist because they are going to be sitting on top of the joist, where a wall that is parallel to it might not be. Next up, let's go ahead and install our floor sheathing. Pan out here. And we had to rearrange the floor up here. The living room is now over here. And I went ahead and I left the closet here, kitchen, bathroom, and bedroom. However, I understand that this wouldn't be a common design. But in such a small building, it's probably not going to matter that much if you have to walk from the bedroom to the closet and then back into here. But I do understand that some people this will not be acceptable. And again, if you don't like this design, you might like it because it's going to save you a few dollars when you install the plumbing, because the kitchen and the bathroom will be stacked over each other. So again, another design option there. And let's go ahead and take a tour of the upper apartment. And our bathroom window, I went ahead and designed this one a little different than the one below also, or should I say the framing on those. Next up, let's install the ceiling joist with our crawl space access hole and our roof rafters. And if you're looking for more information about the roof rafters, you will find it in the video that I already made. And to find that video, you would just need to go through the playlist and look for a roof like this with the word, I believe, apartment in the title, and you should find it. So there we have it, a building with 2 apartments and 1 2-car garage. And as always, if you have any questions or comments, feel free to leave them in the comment area and I will respond to them as soon as possible. In this video, I will provide you with a way that you might be able to use to figure out the overall total rise in a stairway that you cannot just simply grab a measuring tape and measure from the upper level to the lower level because you might have other obstacles in the way preventing it. So let's go ahead and jump into this. The first thing you can do will be to simply grab a level and draw some level lines around the walls if this will work for you. I'm not about to suggest that something like this will work all the time because you don't want to have a line going all the way around your wall. And if that's the case, you don't want a line going around the entire wall, you might be fine with using a level and then just making a mark at the corner, a small mark that you might be able to remove. And I've even made marks like this with a knife, just a little teeny slit that most people are never going to see. And if you need to use a straight edge, a straight board, because your level isn't long enough, then you can always use something like that also. Straight edge or a long board or a longer level. And again, you're going to end up doing the same thing, putting a mark in the other corner. And of course, from this point here, we will grab another straight edge and the level and then go ahead and make another mark. And of course, this mark right here will be the mark we're going to use to figure out the total rise or the difference between the lower level and the upper level. And of course, that method will work if you don't have carpeting. If you have carpeting, it could create another problem. And you might even have a difficult time figuring out the exact total rise, even if you use this method here. So what I'm suggesting here is that you create some type of a component that you can attach to the carpeting, something that will provide you with a firm and secure attachment. And to do this, you could grab a scrap piece of plywood and then screw it into a 2x4 to create some type of a platform like this that can also be screwed and attached to the flooring. And I'll leave it up to you as to how many screws you use. And usually screws can go through the carpeting without creating any problems. However, if this is going to create a problem for you, then I don't suggest using this method. And of course, all you need to do is have the 2x4s a little taller than the top of a landing or the next location that you're going to use so that you can level across to create the first section of the total rise. And of course, this mark can be anywhere here that is lower than the top of this 2x4 or this particular board. And you can always set the level on top of this board also. And of course, the main thing we're trying to do is create level sections that we can measure later. So after we have created a level line here with our level, we can simply mark this 2x4 to create our first leg or our first measurement line, and then simply work our way up the stairway. Like I said, you can put the level on top of it, or I could have this a little bit lower, just as long as I'm creating level sections that I will be able to measure later to figure out the overall total rise. And again, with carpeting and padding, you could end up with a small variation when figuring out the total rise. And of course, all we're going to do here is measure from here to here, and then from here to here, and then from this point here to the top of the carpeting, and then add each one of these measurements together to figure out the total rise. And if you don't like either one of those ideas, you can create a water level and simply hold one end of the water level up, even or flush with the top of the flooring, and then simply work your way over to the other side where the water level can be marked, and then allowing you to measure from this point to figure out the overall total rise for your stairway. That can be used later to figure out the individual riser heights for each step. And in my opinion, if you're looking for accuracy, something like this is probably going to provide you with the best method, especially if your levels are not perfectly level. So keep that in mind also. Check your levels to make sure they are working correctly before using them and finding out that you're a quarter of an inch, a half inch, or even an inch off when trying to figure the total rise for your stairway. Here is another video request from one of our viewers, and in it we will be providing you with some design ideas, not construction assembly ideas, for anyone who might be dealing with an angle, something that is not going to be 90 degrees at the top of your stairway. And of course, in this example here, we have a stairway that is going to come 90 degrees off of the floor. And the stairway, treads, everything. So here we have a standard construction assembly and design. That is not going to be the case if we move this wall and the stairway 22.5 degrees. And the problem I see with this particular design is the fact that the steps will not be the same size. And before building something like this, make sure that you would be allowed to build it in your area. Check with your local building authorities and building codes, because I don't think you would be able to just simply fill in this area here to create your last step. However, I would also like to point out that some building code officials allow for variations like this under certain special circumstances. And if yours falls into that category, then you would be allowed to build it. I also don't think you would be allowed to build something like this because you're not going to have the minimum distance required for your landing or your step. And most steps require a minimum distance between 9 and 11 inches. Now, something like this might work because you now have a landing at the top. It will work if you have the minimum measurement, minimum distance required for the depth of the landing, and that's usually going to be 36 inches. It's got to be 36 inches or larger, and you might not have the room to build a stairway like this. It will depend on if you can move the stairway out a little further. And of course, something like this probably won't work either, but by reshaping the wall framing, you could actually create the 90-degree angles that we need to do something like this. So we would simply add another step to the stairway to where we have a landing that would be flush or even with the upper floor. And in a situation like this, the door could either swing in or out. However, this wouldn't be the case if you were to build it to where the last step was going to be here, because most building codes don't allow for doors to swing over the stairway. It can swing over a landing. It just can't swing over the stairway. And of course, that would look something like this if you had a wall on each side. And I believe that was the example that the individual who asked this question originally had. They had a situation like this. And in my opinion, if you can possibly remodel this area and you have enough room for a stairway like this, then this might solve your problem. And of course, the last suggestion that I have would be to redesign the stairway. And that, of course, will depend upon the design of your project. And if you have any suggestions for something like this, feel free to provide us with a description in the comment area. Or if you have any questions about the video, feel free to leave those in the comment area also.